Hey, in this video, I'm going to give you a common type of particle motion problem that you would see on the AP test. And in this case here, we're going to be using a bug on a wire example, but this could be applied to any type of particle motion. And it says the graph above is y equal v of t, the velocity of a bug that is moving on a horizontal line over the time interval 0 to 8. At t equals 0, the position of the bug is 5 feet from the original starting point. So for the first part, we want to figure out when is the bug at rest. So in this case here, what we're looking for is when is v of t equal to 0. All right, so in this case here, if we look at our graph at t equal 5 and at t equal 8, v of t is equal to 0. Okay, so that would usually is one of the starting points and first part of a particle motion. All right, we'll try part B next. Okay, in part B, we want to evaluate the definite integral from 1 to 6 of v of t dt. We want to explain the meaning of the result. All right, so what we're going to do is we're going to accumulate the area, the signed area from 1 to 6. So if I look at this example here, I can see from 1 to 3, I have a trapezoid. And that area would come out to be 2 plus 1 is 3 times 2 is 6 cut in half. So that area would be 3. From 3 to 5, I have a triangle. And so it's going to be 2 times 2 cut in half. So that would come out to be 2. And now from 5 to 6, I have a triangle, but now it's below the x-axis and we're moving left to right. So that means we're going to take its area, but we're going to have to subtract that off from the 5. So the area of this would be 2 times 1 cut in half is 1, but we want to remember we need to subtract this off of our accumulation for 3 plus 2. So that means that the definite integral from 1 to 6 of v of t dt is equal to 4. And what does that mean? That is the displacement of the bug from t equal 1 to t equal 6. All right, part C, what is the position of the bug at t equal 5? So when we're doing this, we're going to do displacement now at t equal 5, but we have to remember now that the bug started, its original position was 5 feet from the original starting point. So we have to start out with initial value of 5, and then we want from 0 to 5 of v of t dt. And I left the areas written up above in the graph, so we just have to include now, since we're starting at 0, this area of the rectangle here, which will be 1 times 1. So that means that accumulation there would be 6. So that means the bug would be 5 plus 6, so at position 11. Okay, part D, find the total distance traveled by the bug over the interval 0 to 8. All right, so we need to make the distinction between displacement and total distance traveled. So if you want the total distance traveled of the bug, you have to take the absolute value of v of t dt. All right, so in this case here, from 0 to 5, the absolute value of this would remain 6, 1 plus 3 plus 2. But now in this case here, the area of this trapezoid would be, so this is 3, this is 1. We have a height of 2. So this would be 4 as an area, but we're not going to subtract it from this since we're taking the absolute value. We're going to add it to the 5. So our answer would come out equal to 10. All right, part E, our final part. at t equal 2, is the bug speeding up or slowing down? Explain your answer. All right, so when we're looking for speeding up or slowing down or speed increasing, speed decreasing type problems, what we want to do is we want to compare velocity to acceleration. All right, if they have the same sign, that means they're working together, either both positive or both negative. So they can actually be both negative working together, and that will cause a speeding up. If the velocity and acceleration have opposite signs, one positive, one negative, that means they're going to be fighting against each other, and the object, or in this case here, the bug, would be slowing down. So what we want to do is we want to look at v of 2. All right. Well, I can see at v of 2 that we are above the x-axis for v of 2. So v of 2 is positive. All right. So now let's look at the acceleration at 2. Now, how can we determine the acceleration? We don't have a velocity function. We don't have the actual function here, but if we look at the graph, we can see that this part of the graph is linear at t equal 2. So from 1 to 3, we have a line segment there. Well, if we took the derivative of that, which would be the acceleration, what's going to happen here? Well, I can see that this line is moving up from left to right. So that means that my derivative would have to be positive. So that means my acceleration at 2 would have to be greater than 0. So they're both positive, so they're working together. So in this case here, the bug would be speeding up. And our justification would be because v of 2 and a is greater than 0, and a of 2 is greater than 0. And you do have to justify that. Okay, I hope that helps you with particle motion. Please like the video and subscribe. Thanks again.